Okay, so we're going to look at evaluating exponents that have fractions involved in them. And in this case, we have fractions as the base and the exponent themselves. So the reason we say evaluating is because, as you'll see here, we have a whole bunch of terms, and we're going to try to evaluate all of this information without a calculator, which could prove to be somewhat difficult. We'll see. It's going to be a long one. So what we're going to do is we're kind of just going to focus them at term at a time. And the way terms are separated are essentially by addition, or there's no subtraction here, or subtraction signs. That would be the other one. Okay. Everything else, if there's multiplication and division, they're kind of, think of them as what's going to be simplified into one term. So this is 8 over 27 to the power of negative 1 over 3. So first of all, our exponent is a fraction, which means it's a root. I'm going to write a little rule here that if we have x to the power of a over b, okay, we should write this little rule in so we know. It is the equivalent of writing the b root, so whatever b is, to the power of a. Okay, so we can rearrange it to be a root type function. So because this is fractional and it's a negative exponent, we can get rid of the negative by inverting the fraction. Okay, so the next line here, actually I'll highlight it so we'll do piece by piece. We'll work with just yellow to start. And I'll write yellow in black. No, I should write yellow in red. Okay, so we're just going to evaluate that. So I want this to be a positive exponent, so I invert the fraction. 27 over 8 to the power of positive a third. Okay, so I've now changed this to be positive, and we just have to invert the fraction to do something like that. The next step is this is a root, and this root is technically applied to both of the terms, both the denominator and numerator of this fraction. And remember, we can write the root like this. This 3 becomes the third root, and then we can put this to the power of 1. So we have the third root, and both of the fractional values are now to the exponent of 1. So we'll do it down here. So we get the third root of 27 to the power of 1 over the third root of 8 to the power of 1. What's 27 to the power of 1? What's anything to the power of 1? Can you think of it? Like 5 to the power of 1, 2 to the power of 1?
Just itself.
Yeah, it's just itself. It doesn't change. So these powers of 1s are redundant. We don't need to write them in. So essentially, we need the third root of 27. So we can do that with a calculator if we're unsure, but we said we want to try this without calculators. So I'm looking for a number that timesing itself 3 times will give us 27. I don't know if you know this off the top of your head.
3.
3, that's right. 3 to the power of 3 is 27. So the third root of 27 is just 3. Okay. Now I need the third root of 8. A number times itself 3 times, that will equal 8. 2. So the third root of 8 is 2. So in other words, this very complicated looking 8 over 27 to the power of negative 1 over 3 is the equivalent of 3 over 2. Right? A very just complicated way of writing that. Now, let's do the next step. Let's work on this one. This one's a little simpler. We'll do this in green. I'll drop an arrow down. What we'll say is, let's just go on the assumption that I wrote it all the way down to here. Okay, so now we have our plus this green here. So I'll rewrite it again. Negative a half to the power of 3. Okay, so the first thing we look at, just like we did before, is our exponent. Is it positive or negative? In this case, it's positive. So we don't have to do any inverting of the fraction. What we can do now, there's 2 ways to really look at this. We can say we do a negative half times a negative a half times a negative a half. Whoops. All right, because that's what power of 3 is. We multiply 3 times itself. Another way we could do this is we can evaluate whether our answer is going to be positive or negative, and then just apply the power of 3 to both the numerator and the denominator. There's really no difference in this process. Okay, so let's think about this. A negative times a negative times a negative. Do you know what our answer is going to be in the end there?
Negative.
A negative, that's right. Negative is positive times another negative gives us a negative. So our next one here, I'm just going to assume this is the same. We know our answer is going to be negative. Doesn't matter what it is. So I'm going to draw the negative outside of a set of brackets. And now I have 1 to the power of 3 over 2 to the power of 3. Okay. When we do that, 1 to the power of 3 is just 1. And 2 to the power of 3 is 8. We actually solved that before. We used that as a root. So now we have 3 over 2 plus 1 over 8. And then finally, we're going to evaluate this 4 over 3. bring it all the way down to here. So plus 4 over 3. Or 4 to the power of negative 3, I should say. So it's a negative exponent. That's the first thing we're talking about. So what I want to do here is I actually want to make this a fraction. I can make 4 a fraction by just putting it over 1. Makes no difference. And I want this to now be positive. So because I want it to be positive, the next line I have to invert this fraction. So now it becomes 1 over 4 to the power of 3. Okay. Now, in this version, I brought the exponent in to calculate. In this one, what I'll do is I'll show you multiplying it by itself 3 times. So we now have another line here. So essentially, it's 1 over 4 times 1 over 4 times 1 over 4. There's no difference from what we did over here. I'm just showing you another method. Okay. So think of it like this. 1 times 1 times 1 is 1. This is the tough part. 4 times 4 is 16 times 4. So I'll do a little calculation on the side, and it should be 64. So it's 1 over 64. So now let's take a look at all of our stuff again. We have 3 over 2 plus 1 over 8 plus 64. Now I did quite a few steps in between here to solve all of this. Now we're going to actually add these fractions together. So this is no longer really the exponent stuff, but this is more basic fraction rules. We need the denominators to all be the same. In order to get 2 to be the same as 64, I got to multiply both the top and the bottom by 32. It's a pretty big number, at least for being in our head. So our denominator is 64. Our numerator is going to be 696. Okay. In order to get 8 to be 64, I got to multiply both the top and the bottom by 8. So we're going to play plus 8 over 64. And in order to make 1 over 64, I have to do absolutely nothing. Our denominator is going to be 64. And now we're just adding these values. 8 plus 1 is 9. 9 plus 96 should be 105. So our answer to this complex looking question is 105 over 64. And then we could reduce the fraction and such if it's possible, but this is essentially the answer you're looking for. Okay.